to this video for 9.4 constant acceleration formula 2. These are the examples for 9D. Okay, so what we're going to do here is we're going to first of all derive the remaining three kinematics formulae or Suvat equations, and then we're going to use them in applied problems. Okay, so the textbook goes through it for you like this, but I'm going to start from here. Okay, so these are all five of the formulae, and what we've derived so far is these two from the graphs. Okay, so we need to now derive these final three, and you'd be expected to do this in an exam. Okay, first of all, the first one we're going to do is we're going to substitute this equation here directly into this equation here. Okay, so we're going to substitute u plus at in for v. Okay, so S is equal to u plus u plus at all over 2 multiplied by t. I'm now going to simplify the top to u plus at all over 2 multiplied by t. I'm now going to divide everything on the top, the numerator of the fraction, by 2. And then multiply through by t. So ut plus half at squared. And we've got this one here. Okay, so simply the first easiest one to do, substitute this one straight in for v here. Okay, now what the other things we could do, we could substitute u into here. Okay, we can eliminate u. So what we need to first of all do is rearrange, so u is the subject. So u is equal to v minus at. Okay, we're now going to substitute that in for this u here. So let's use a different colour. S is equal to v minus at plus v. Okay, simplify the top. Then you divide by 2. And then multiply it by t. And there you have the second, the last one down here. Okay, final one. So sort of a little framework here. You need to rearrange it. That you say your subject is t, and then you need to substitute it in for this t here. Okay, and that's what you have to do in all of them really. You get rid of that. So rearranging. Go with the purple. So v minus u divided by a. We're then going to substitute in for this t, eliminate the t. Okay, then we're going to multiply the two brackets together. So I can see, so to separate the numerator and the denominator, the numerator u plus v multiplied by v minus u. That's a difference of two squares. So it's going to give us u squared. No, it's not. It's going to be v squared minus u squared. And on the bottom, we've got 2a. We then need to rearrange, so I'm going to multiply by 2a on both sides. 2as is equal to v squared minus u squared. And then I'm going to add on the u squared. Swap them around, so v squared is equal to u squared plus 2as. Okay, and that is your final derived formula. Okay, so like I said before, you need to be able to derive these from that graph, and then all of these can be derived by substituting and eliminating one of the variables. Okay, a particle is moved along a straight line from A to B, A, B, with a constant acceleration of 5 meters per second. So A equals 5. Velocity at A is 3 meters per second. So the initial velocity, the velocity at B is 18. The final velocity find the distance from A to B. So we're interested in this distance here. Okay, so I've drawn a little diagram to imagine the situation. I'm then going to write out SUV A T. So S we're trying to find, U is 3, V 18, A is 5, T not in the question. We want to find S, and we want the one that hasn't got T in. So the only one that's not got T in is here, V squared equals U squared plus 2AS. So I'm going to substitute it straight in. So you've got 18 squared is equal to 3 squared plus 2 times 5 times S. Work some of this stuff out. 3, 2, 4, 9 plus 10 S. Just going to rearrange it a bit. So we've got 10 S is equal to 324 minus 9. So S is equal to 31.5. Remember your units, it's distance, and the distance in this question is meters because we're working in meters per second for the velocity, 31.5. Example 8. Particle is moving in a straight horizontal line with a constant deceleration of 4 meters per second. Okay, so this is important now. So it's moving in this direction, but the acceleration is negative because it's a deceleration, 4 meters per second squared. Time t, it passes through the point 0 with a speed of 13 meters per second. Where OA is 20 meters. Here's A, and this is 20 meters, and that's equal to S. Right, we need the times where the particle passes through A. There's a subtle S on the end there. We'll see where that comes into it in a minute. So S, U, V, A, T. S is 20, U's 13, V, we don't know, and we don't have in the question. A is -4, and the time is what we're trying to find out. Okay, so we want the one that hasn't got V in, which is this here. So we're going to substitute the numbers in. 20 is equal to 13t plus half times A times t squared. Half times -4 times by t squared. So let's simplify it first. Half times -4 is -2. Right, we've got a t and a t squared, so we've got a quadratic here. So we need to rearrange it so it's equal to 0. So we're going to have 2t squared minus 13t plus 20 equals 0. And then, can you factorise it? This is a difficult one to factorise, so we better get our calculators out. So you can use the function on your calculator to solve it for you. I know it was an easy one to factorise this one. So it's 4 and 2.5. So t is equal to 4. T is equal to 2.5 seconds. So the times it passes through A are 2.5. So it initially passes after 2.5 seconds, but remember it's decelerating. It gets to a point over here where it gets to 0 velocity, and because it's still decelerating, it starts to become negative velocity, which means it's moving back towards the initial starting point. Okay, so you get 2.5 seconds on the way out, 4 seconds on the way back. Okay, it says then the value of t when the particle returns to O. Change colours. B, S, U, V, A, T. So S is, now when it returns to 0 or O, then the displacement is 0. The initial speed is still 13. We don't have V, so we're not going to use that. This is -4, and time is what we're after. Okay, so it's the same scenario as the previous one. 0 is equal to 13t minus, let's do the multiplication straight away, 2t squared, rearrange, 2t squared minus 13t equals 0. I'm going to take t outside, so we've got 2t minus 13 inside. So either t is equal to 0, which would have been at the start of the question, so we're not using that one, or t is equal to, so it would be 13 over 2, 6.5 seconds. And that will be the point where